In this laboratory, the materials that we prepare are the TLD511 or transmission line demonstrator, function generator or feedback VPG608, an oscilloscope, and 600 ohms resistor and 2 shorting links. Set the TDL511 controls as follows. Hold run, set to run, line length set to 8L, and distributed attenuation set to minimum. The function generator's frequency should be initially set to 0.75 and the output voltage is set to 0. Next, connect one link and the 600 ohms resistor on the line termination B. And then connect one link on the line termination A. Connect the probe on the channel 1 of the oscillator and connect the end probes of the oscilloscope on the yellow terminal. Make sure that the end probes of the oscilloscope are steady. The positive and negative terminal on A is connected on the yellow and black terminal on the function generator respectively. The probe of the oscilloscope is connected to the yellow terminal and its ground is connected to the black. Operate the switch for step input to A. The switch should be released after light has appeared on the second column. Repeated operations of step input to A can send patterns of pulses like Morse code along the line. While switching the step input to A, observe the pulses generated on the oscilloscope. The generated pulses can be observed as Morse code, which consists of short and long pulses. The reverse propagation of pulses is generated when switching the step input to B on the TLD511. As you can see while switching, the pulses can be seen on the oscilloscope. The short pulses can be interpreted as the dot, while the long pulses can be interpreted as the spaces on the Morse code.
This experiment shows how patterns of pulses are being generated on the transmission line demonstrator when the switch is set to step input to A and also to step input to B. Moreover, the oscilloscope shows the pattern of pulses that are generated in the TLD511. In this experiment, it shows the information or the pulse wave is propagated in an ideal non-reflecting transmission line where no distortion and attenuation affect the shape of the wave. In this laboratory, the transmission line demonstrator was terminated with a 600 ohm resistor to match the 600 ohm characteristic impedance of the line. This was done to simulate an ideal non-reflecting transmission line used by the students, since matching the impedance will result in maximum power transfer and therefore is an ideal transmission line.
At the end of this experiment, the students were able to simulate, visualize, and display the propagation of a disturbance in wave under matched conditions using the TLD511 and the oscilloscope. The results of the experiment showed that a wave traveling through a properly terminated line has a constant amplitude through the transmission line. It was observed that there were no reflections of the simulated transmitted data, in this case, the Morse code of the word ECE, on the TLD511 display. Moreover, the oscilloscope probing the output side of the TLD511 showed that the amplitude of the transmitted pulses were consistent with those seen on the display. Following these observations, it may be concluded that in a non-reflective and lossless line, there are no disturbances that could impede the transmission of the desired signal.